Velocity time graph and displacement time graph. Velocity time graphs. Velocity time graphs are used to represent the motion of the objects whose velocity is constantly changing. To draw this graph you need a record of the velocity of an object at different times. Example 1. The record of the speed of the car every 5 seconds using the table below. Use the table to produce a velocity time graph. The table records indicate that at 0 seconds the velocity is 0 km per hour. At 5 seconds the velocity is 10 km per hour. At 10 seconds the velocity is 20 km per hour. At 15 seconds the velocity is 30 km per hour. At 20 seconds the velocity is 40 km per hour. At 25 seconds the velocity is 50 km per hour. At 30 seconds the velocity is 60 km per hour. It is readily apparent that the graph is a straight line and that it represents an increase in velocity by 10 km per hour during each 5-second interval. This is an acceleration of 2.0 km per hour per second. Since the acceleration for each interval is the same, the graph illustrates uniform acceleration. You will find that whenever a velocity time graph is a straight line, it represents uniform acceleration. Solution. Applying the equation A equals V minus U over T to the graph for the time interval 0 to 30 seconds results in acceleration equals 60 km per hour minus 0 over 30 seconds equals 2.5 km per hour per second. To determine acceleration from a velocity versus time graph, you simply calculate its slope or gradient. Note that V bar is the rise and T is the run. Example 2. Use the following velocity time graph to determine this object's acceleration for the first 10 seconds of its motion, and the time interval of 10 seconds to 15 seconds. Acceleration is equal to the slope of a velocity time graph. Acceleration on a velocity time graph. Solution. V equals 25 meters per second minus 0 meters per second equals 25 meters per second. T equals 10 seconds. A. Acceleration equals change in velocity over change in time. This is equals 25 meters per second over 10 seconds equals 2.5 meters per second squared. B. Acceleration equals change in velocity over change in time equals 30 meters per second 25 meters per second over 5.0 seconds equals 1.0 meters per second squared. Positive, negative, and zero acceleration. Examine the following velocity time graph. On it you will find examples of 3 different kinds of acceleration. The object starts off from rest, at 0 velocity, and accelerates steadily for a while. After 10 seconds, it stops accelerating and then travels at a constant velocity for 10 seconds. The slope of this part of the graph is 0, telling you that the acceleration is 0. Now the object slows down. In each second, it does the same amount of velocity. The slope of the graph in this section is negative, making the acceleration negative. If line segment C were extended so that it were below the time axis, the acceleration would still be negative. However, the object would now be moving faster and faster in negative direction. The acceleration for each section is calculated as follows. A change in velocity equals 20 meters per second. Change in time equals 10 seconds. Acceleration equals 20 meters per second over 10s equals positive 2.0 meters per second POWER2. Increasing velocity. B. Here the change in velocity equals 0 meters per second. Change in time equals 10 seconds. Acceleration equals 0 meters per second over 10 seconds equals 0 meters per second power 2. Constant velocity. C. Change in velocity equals minus 20 meters per second. Change in time equals 8.0 seconds. Acceleration equals minus 20 meters per second over 8.0 seconds equals minus 2.5 meters per second power squared. Decreasing velocity. Remark, on a velocity time graph. The straight line sloping upwards indicates uniform acceleration. A straight line sloping downwards indicates deceleration. A horizontal line indicates zero acceleration, i.e. constant velocity. Velocity time graphs and displacement time graphs. The motion of a body moving with a constant velocity of 50 meters per second for 6 seconds may be represented graphically as shown in figure below. Constant velocity on a velocity time graph. The area under the graph is found by multiplying length by breadth. Since length is the velocity axis while breadth is the time axis, the area under the velocity time graph is numerically equal to the distance covered during the time shown. In this case, distance equals 50 times 6 equals 300 meters. Constant velocity of a displacement time graph. If the displacement moved each second is 50 meters per second times 1 seconds equals 50 meters. The information can be represented on a displacement time graph as in next figure. Since v equals x over t, the velocity is equal to the slope, gradient, of the displacement time graph. In uniformly accelerated motion, the velocity of a body increases by equal amount in equal times. The graphs below represent this motion. Graph A shows the case where u equals 0, initial velocity. Graph B shows the case where u equals 10 meters per second. Area equals distance. In both cases, the area under the graph curve represents the distance covered in 5 seconds. For A, x equals area of triangle equals 1 over 2 times 5 times 20 equals 50 meters. For B, x equals area of trapezium equals 1 over 2, 30 plus 10, times 5 equals 100 meters. For A equals v over t equals 20 minus 0, over 5 equals 4 meters per second squared. For B, A equals 30 minus 10, over 5 equals 4 meters per second squared. Example 1. Find the total distance the moving object travels as represented in the figure below. Solution. A. Height equals 30 and base equals 5. Area 1 equals 1 over 2 times base times height, that is, 1 over 2 times 5 times 30 equals 75 meters. B. Breadth equals 10 minus 5 and length equals 30. Area 2 equals LB equals 10s minus 5s times 30 equals 150 meters. C. Short base B equals 20, larger base B equals 30 and height equals 15-10 equals 5. Area 3 equals 1 over 2, short base plus larger base, times height, that is equal to 1 over 2 times 20 plus 30, times 5. Equals 1 over 2 times 50 times 5 equals 125 meters. D. Short base equals 20 minus 15 equals 5, larger base equals 25 minus 15 equals 10 and height equals 20. Area 4 equals 1 over 2 times short base plus larger base, times height, this is equal to equals 1 over 2 times 5 plus 10, times 20. Equals 1 over 2 times 15 times 20 equals 150 meters. Total distance equals 75 meters plus 150 meters plus 125 meters plus 150 meters equals 500 meters. Example 2. A body moving from rest acquires a velocity of 40 meters per second in 4 seconds. It moves with this velocity for 6 seconds and again accelerates to 60 meters per second in 5 seconds. It travels for 5 seconds at this velocity and then comes to rest with uniform deceleration in 10 seconds. Draw a velocity time graph for this motion and use it to calculate A. The acceleration while the velocity changes from 0 to 20 meters per second. B. The acceleration while it changes from 20 to 30 meters per second. C. The retardation. D. The total distance covered. E. The average speed of the whole motion. Solution. A. Acceleration equals velocity over time equals 40 minus 0, over 4 equals 10 meters per second squared. B. Acceleration equals 60 minus 40, over 5 equals 4 meters per second squared. C. acceleration equals 0 minus 60, over 10 equals minus 6 meters per second squared. D. The total area may be obtained by adding the areas of sections A, B, C, D, E and F, which are triangles, rectangles, or trapezia. But here we can combine A, B, C, D, and E, F to ease the process. A plus CD plus F equals 1/2, 10 plus 6, times 40 plus 1/2, 60 plus 40, times 5 plus 1/2, 15 plus 5, times 30. Equals 320 meters plus 250 meters plus 300 meters. Equals 870 meters. Average speed equals total distance covered, over, total time taken, equals 870 meters over 30 seconds equals 29 meters per second. Thanks for your attention. Kindly like and share our videos. Please don't forget to subscribe and press the notification bell to be the first to receive the next learning video. You may also give us a comment to suggest what topic you would like us to cover. Also, follow the link in the description to learn more on this topic. See you later.